Data centers are the unseen engine driving the digital age, silently powering everything from streaming your favorite show to training the world's most powerful AI models. This video explores the rapid growth and demand for these indispensable facilities and what their rise means for our society, environment, and future. Chapter 1 focuses on the unprecedented surge. The data center industry is experiencing explosive growth, driven by artificial intelligence, cloud migration, and the relentless expansion of digital infrastructure worldwide. The AI tsunami is driving a 14% compound annual growth rate through 2030 for the global data center sector. Key drivers include AI workloads, which will account for half of all data center workloads by 2030, and the surge in AI inference demand. This growth demands a monumental build-out, doubling global capacity within a single decade. We expect 100 gigawatts of new capacity by 2030, doubling the existing global data center infrastructure to a total capacity of 200 gigawatts. The industry is amid a $3 trillion infrastructure supercycle. This investment, including real estate and capital expenditure, is expected to generate $1.2 trillion in real estate asset value from new capacity alone, establishing data centers as a key asset class of the decade. This scale of development confirms that, quote, the digital backbone is expanding at warp speed. A global frenzy is underway, with 23.1 gigawatts under construction as of late 2025. The Americas dominate, but APAC and EMEA are aggressively ramping up their data center capacity. Big Tech's capital expenditure explosion is fueling this. The 14 largest operators are nearing $750 billion in spending in 2026. This reflects that AI infrastructure is now a core strategic priority, driving a race for power, land, and fiber. Chapter 2 asks, why are data centers so crucial? They are the physical foundation of the digital economy, enabling services, industries, and human activities every second of every day. Data centers are the heartbeat of AI and cloud computing. AI workloads require 3 to 5 times more compute, relying on data centers for massive training and real-time inference delivery. No advanced AI is possible without this physical infrastructure. Beyond AI, data centers are the foundation of modern life. They power global streaming, support IoT and smart cities, run crucial science and research simulations, and enable remote work and collaboration through cloud infrastructure. From your pocket to the cloud, it all connects here. Every smartphone tap triggers a chain of events, spanning continents, moving data through fiber cables and into a data center and back, all in milliseconds. This is an extraordinary feat of engineering. The IT infrastructure landscape is shifting with record demand and vanishing supply. Co-location absorption is at record highs, dropping North American primary market vacancy below 3%. Meanwhile, cloud migration drives a 6% decline in traditional on-premises capacity. The future is the hybrid portfolio. Organizations blend on-premises infrastructure for sensitive workloads, co-location for capacity, hyperscale cloud for elasticity, and edge computing for low-latency applications. This strategy delivers the optimal balance of performance and cost. Chapter 3 explores the environmental and social footprint. The explosive growth of data centers has profound consequences for energy systems, water resources, communities, and the planet. Managing this footprint is a defining challenge of the digital age. Data centers are power-hungry giants. Global data center electricity demand is estimated to reach 945 terawatt-hours by 2026, which is more than the annual energy output of many mid-sized nations. Power availability has now become the #1 site selection factor. Securing a reliable, sufficient power supply is now the single greatest challenge and competitive advantage in the modern data center industry. Kilowatts have become the 21st century's most important commodity. Water usage is another growing concern. Data centers rely heavily on evaporative cooling towers, consuming millions of gallons of water per day. Innovations like liquid cooling and closed-loop systems are emerging to address this challenge. The rapid pace of AI innovation creates a massive e-waste challenge. Hardware obsolescence is driving frequent replacements. To combat toxic disposal risks, operators are investing in circular economy solutions like component harvesting and closed-loop recycling. Data center developments often face community opposition due to noise, visual impact, and strain on local power grids. Proactive engagement with local governments and residents is essential for faster permitting and better project outcomes. Chapter 4. Navigating the future landscape. The next phase of growth will be defined by solving critical constraints: power, design density, construction execution, and the rise of sovereign digital infrastructure. Power is the ultimate constraint. Multi-year grid connection wait times there, forcing a shift to behind-the-meter strategies. This includes co-located solar farms, battery storage, and even emerging small modular nuclear reactors. Forward-thinking operators are building energy-independent campuses pairing renewables and storage to guarantee the power certainty required by continuous AI workloads. AI is fundamentally reshaping facility design. Traditional centers were 5 to 10 kilowatts per rack. Current AI facilities are near 100 kilowatts. Next-generation designs are anticipated to push 200 to 400 kilowatts per rack, demanding entirely new thermal and structural approaches. Construction delays and execution risk are key concerns. Over half of 2025 projects face delays due to shortages in transformers and specialized labor. Large AI campuses now have multi-year timelines with built-in cost inflation assumptions. AI infrastructure is a national security concern, driving the rise of sovereign AI clouds. Data privacy laws and government investments are fueling development in regions like Europe and the Middle East to ensure digital independence. India is emerging as a global opportunity, focusing on AI infrastructure and national sovereignty, leveraging its 520 gigawatts national power grid. Development is shifting to capacity-focused hubs like Hyderabad and Vizag. The global network is expanding and evolving rapidly. New hubs across Asia, the Middle East, Africa, and Latin America are emerging as digital demand proliferates, and sovereign AI infrastructure becomes a national priority everywhere. Investor priorities must adapt. They should prioritize AI-capable or retrofit-ready assets and use sophisticated capital structures like ABS and CMBS. Positioning ahead of regulation, especially in ESG, is critical for future capital flows. Corporate priorities must also shift. Secure long-term power capacity agreements early, as delivery can take years. Design facilities for flexibility to accommodate higher densities and new cooling technologies. Finally, build construction and supply chain risks into all deployment plans. We now enter Chapter 5, the vision ahead. The data center industry is at a pivotal crossroads, balancing explosive demand with environmental responsibility. The choices made in the next 5 years will define its long-term legacy. The defining challenge is achieving a sustainable digital future. Exponential growth in compute demand clashes with increasing energy consumption, rising water usage, and accelerating hardware waste. The path forward includes renewable energy procurement, advanced cooling, waste heat recovery, and circular economy programs. Forward-looking operators show that sustainability and performance are complementary goals. Renewable-powered, water-efficient, and thoughtfully sited data centers represent the template for the next generation of digital infrastructure, embracing green infrastructure with powerful ambition. The data center has transformed into a strategic asset. It is now recognized as critical national AI infrastructure, a pillar of digital sovereignty and geopolitical power, and a major economic engine generating jobs and innovation. The unseen engine continues to power our future. Demand will surge, driven by AI and cloud computing. Solving constraints like power and sustainability requires bold innovation and responsible stewardship. The data centers built today will shape the digital world for the next 30 years.